Today we are going to continue to work with complex numbers. By definition, complex numbers are any number that are in the form a plus bi, where a and b are real and I is imaginary. Let's look at some problems that you tried last night. When you are asked to multiply two imaginary numbers, now these are imaginary, there is not a real component. A plus bi is a complex number where a is the real component and b is the imaginary component. So if we're looking at this first example, there is not a real component. When you multiply negative 4i times 7i, you're going to multiply the coefficients. So negative 4 times 7 gives me negative 28. And I times I is going to give me I squared. Now, by definition, yesterday you should have learned that I squared is equal to negative 1. That may also be written as I equals the square root of negative 1. So when I look at the value here, I squared, I am going to replace that with negative 1. So I have negative 28 times a negative 1, and a negative times a negative is a positive. So the simplified form would be positive 28. All right, let's try example number 2. Now it's asking me to multiply two terms where you have a negative value underneath the root. Well, in order to work through multiplication, your job is always to take the I out first, or to get rid of that negative value underneath the root. So when you're looking at that problem, you have the square root of negative 8 times the square root of negative 5. Now, this negative 8 is the same thing as negative 1 times 8. And the negative 5 is the same thing as negative 1 times 5. Now, we know by definition that I squared is negative 1. So where I see the negative 1 in each one of these positions, I'm going to replace that with I squared. So this is now the same thing as I squared times 8 and I squared times 5. Well, your job is to look for pairs. So anywhere I see an I squared, that's my pair, I can pull this out as a single I. So I'm going to pull an I out front here as well. I'm going to pull an I out front. Now, I'm also going to reduce this 8. So if you go through and you look at a factor tree, 8 is the same thing as 2 times 2 times 2. 5, on the other hand, cannot be broken up. So if I think about these values underneath, if it's a square root, I'm looking for a pair. So not only was I able to pull this I out, but I'm also going to pull out a pair of 2's. So the final simplified form for my first term would be 2i square root of 2. And my second term, the 5 again doesn't break up, so that's going to be I square root of 5. I still haven't gone through and multiplied. So if I do that last step, 2i times I is going to give me 2i squared. Square root of 2 times square root of 5 is going to give me a square root of 10. Now I'm still not done because I have an I squared, and we know I squared by definition is a negative 1. So this is the same thing as 2 times negative 1 times root 10. So my final simplified form is going to be negative 2 square root of 10. All right, one more. I to the 19th. Now, our job again is to simplify. So we're trying to make that as small as possible. Well, since this is odd, I'm going to break this up into the closest even, or break that down. So this is the same thing as 1i times I to the 18th. Well, I to the 18th. that is the same thing as I squared to the 9th. I squared again, we know is -1. So I'm going to replace that I squared with a -1. So I have this I, a -1 to the 9th. Any negative raised to the odd power is going to stay negative. So now I have I times -1, which is going to give me -I. Now, I showed you a tremendous amount of work for this one. I also showed you a tremendous amount of work as this. So as you get more comfortable as you work through the problems, you maybe might want to modify that a bit. Okay, now it's your turn. I'm going to give you a couple minutes to try these 3 problems. So please pause your video and give those a shot. All right, hopefully we're ready to try these together. So number 1, you have -5i, and you're going to multiply that by -3i. I put these in parentheses just to make sure that I'm not losing track of this negative. So we're going to multiply these first. -5 times -3 is going to give me a +15, and my I times my I is going to give me I squared. Now, to remind ourselves, by definition, I squared is -1. So in this position for my I squared, I'm going to replace that with a -1. So 15 times -1 is going to give me a -15. Boom. Number 2, 3 is my coefficient. I have the square root of -6. There's no coefficient here that's written, so that always is going to be a 1 times the square root of -3. Now again, we multiply. The definition of multiplication for radicals only applies if there is not a negative underneath. That radicand has to be positive. It has to be a real value. And again, these are imaginary because you're not allowed to leave a negative under the root. So same process as before. I'm still going to show a bunch of work here, but please modify as you keep going. -6 is the same as -1 times 6. -3 is the same thing as -1 times 3. By definition, -1 is the same as I squared. So in place of those -1s, I'm going to rewrite that as I squared times 6. And instead of this -1 again, I'm going to write that as I squared times 3. So my goal is to look for squares, terms that you see 2 times. Well, I see 2 i's. The 6 is really 2 times 3. There is not a pair there, so I'm going to be stuck with that 6 inside. Here's another I squared. I'm going to be able to pull an I out there. This value also goes nowhere. There is not a pair. So let's simplify these radicals one more time. This is going to come out as an I. This is also going to come out as an I. So now I have 3i times the square root of 6. Here I have 1i times the square root of 3. So when I do that multiplication step, 3i times 1i gives me 3i squared. I have root 6 and root 3, which is going to be square root of 18. The I squared I can replace with a -1. So I'm going to have 3 times -1, which is going to leave me with a -3. The 18 does break down. This is 9 times 2, so you have a 3 and a 3 and a 2. I have a pair of 2s or pair of 3s there. So that's going to bring 1 3 out. So my final product is going to be -9 root 2. All right, last one. You're left with an odd exponent or given an odd exponent. So I'm going to decrease that by 1. So this is to the first. That's going to give me an I to the 12th. And again, I know that because if the bases are the same, you're going to add the exponents. Bases are the same. So 1 plus 12 gave me a 13. This I to the first is going to stay. I to the 12th is the same thing as I squared to the 6. Again, this is a product here between the 2 and the 6, which gives me that 12. By definition, again, we know that I squared is -1. So I have my I here. I have I squared, which is a -1 A negative 1 to an even becomes a positive 1. So this value is going to become a positive 1. And 1 times I is going to give me a positive I. Operations with complex numbers. This is real similar to working with polynomials. I can add, subtract, multiply, and divide complex numbers. If I'm going to focus on adding and subtracting, I'm just going to combine my like terms. So you're going to combine your real portions of your complex number and the imaginary component of that complex number. All right, multiplying. When you multiply, you're going to multiply the terms using the same method you would multiplying two polynomials. So you're going to be distributing, you might be foiling. Dividing is a little bit more challenging. You're going to work on rationalizing the denominator. And what that means is you can have no I left in the denominator. I represents a square root. And when we are reviewing our radicals, we know that we can't leave a root in the bottom. All right, let's give these a shot. So you have 8 minus 3i, and that's just written in parentheses to emphasize that it's the a plus bi, which is our complex number. This a, again, is my real component, and this b is my imaginary component. So 8 minus 3i, and I'm going to add to that 2 plus 5i. So I'm going to identify my real components. So my real components here, I have the 8 and I have the 2. So I'm going to add those. 8 plus 2 gives me 10. And then I have my imaginary components, this negative 3i and this 5i. And again, I'm adding because this is an addition operation. You're adding these two complex numbers. So 8 plus 2 gave me 10. Negative 3i plus 5i is going to give me a positive 2i. And that's it. Example 5, you are subtracting 16 minus 4i, and you're going to take away 12 minus 3i. Now, you are subtracting a binomial, and when we subtract binomials, we have to distribute that because truly that is a negative 1 as a coefficient. So I'm going to rewrite that as 16 minus 4i, negative 1 times 12 gives me a negative 12. Negative 1 times negative 3 is going to give me a positive 3i. And now I'm just going to add my like terms. So I'm going to add my real components. In this case, you're subtracting. And then I'm going to add my imaginary components. Okay, so when I add my real ones, I have 16 minus 12, which is going to give me a positive 4. And I have negative 4i plus 3i, which is going to give me a negative I. All right, it's your turn. Give these a try. Please pause your video and see how these work out for you. I just realized number 4 is a problem that I did as an example. So why don't you skip that one and go on to 5 and 6. Okay, these should have gone pretty quick. They're very basic problems. So for the first one, I have 3i plus 7, and I am adding to that 34 minus 6i. I'm going to combine my real components and my imaginary components. So I have a 7 and a 34, and I'm going to write that value first because that would be my real component. A plus bi is the form that you see for complex numbers. So to keep it in that form, 34 plus 7 is going to give me a 41. And then if I look at my imaginary components, which are 3i and negative 6i, that is going to give me a negative 3i. So I wrote that addition there. You can write that as adding the opposite if you choose, or rewrite that as 41 minus 3i. Last one, negative 4 plus 7i. You are adding 8 minus 9i. No need for those parentheses. They are written there for you, but really they're there just to truly separate those terms. I have my real components, negative 4 and 8, And I have my imaginary components, which were 7i and negative 9i. So let's walk through that. You have 8 minus 4, which is going to give you a positive 4. And you have 7i. Taking 9i away, you are down 2i. Here are 2 more problems for you to try. First one, subtraction, and second one, slightly more difficult. Give those a shot. Please pause your video. All right, let's give those a shot. See how you do. So you have the first one. Again, this is a little bit different because you are subtracting. The parentheses are still just separating those 2 complex numbers. And again, A plus BI is the format that you're going to write it. So I'm going to get rid of these parentheses, but that means I'm going to actually have to take this negative and distribute it through. So I have a negative 1 minus I. Negative times a negative is going to give me a positive 3. A negative times a negative again is going to give me a positive 4i. Let's look at those values. I have a real component here and an imaginary component here. So that's going to give me 3 minus 1, which is going to give me 2. And 4i minus 1i is going to give me 3i. The last one, number 8, you have 2 in parentheses, 3i plus 7. And it doesn't make a difference that it's not written in order. We just want to make sure that we write our final form in that proper complex order formation. So let's get rid of these parentheses. 2 times 3 is going to give me 6i. 2 times 7 is going to give me 14. 5 times negative 4 is going to give me a negative 20. And 5 times I is going to give me a 5i. Identifying those parts one more time. I have my real components and my imaginary components. So if I'm looking at my real components, I'm going to have negative 20 plus 14, which is going to give me a negative 6. And 6i and 5i is going to give me an 11i. Okay, let's work on multiplying. Example number 6 we already tried. And that's when you have to get this negative outside of the parentheses first before you actually go through and do a multiplication. So I'm happy with that square root of 3. The negative root 12, again, that's the same thing as negative 1 times 12. As I rewrite this again, I'm going to break that 12 up as well. So the negative 1 is the same as my I squared. 12 is 2 times 2 times 3, because that would be 4 times 3. I'm going to take all of my pairs out. So I have a pair of 2's and I have a pair of i's. So this is going to come out as a singleton I. This is going to come out as a singleton 2, and my loner 3 is stuck inside. So I have now 1 root 3. I'm going to times that by 2i root 3. So doing that multiplication step, 1 times 2 is going to give me 2. So I have 2i. Square root of 3 and square root of 3 is square root of 9. That is a perfect square. I know that square root of 9 is 3. So that's going to leave me with 2 times I times 3, which is 6i. All right, the next one, you're actually multiplying complex numbers. Why in that first one, that example 6, those were multiplying radicals. So when you're multiplying 2 complex numbers, you actually have to use that FOIL acronym, which is first, outer, inner, last. So I'm going to multiply my first terms, 3 times 5. I'm going to multiply 3 times 3i, negative 2i times 5. And my last one, negative 2i times 3i is going to give me a negative 6i squared. So we're going to combine our terms, but first, look at this, I squared. I squared I know is negative 1. So I'm really looking at negative 6 times negative 1. So this last term is going to be instead right here is going to end up giving me a positive 6. So let's look at our parts. We have 15 and we're adding 6. That's going to give me 21. And I have 9i. I'm taking 10i away, so I'm going to down 1i. These are for you. See what you can do. Please pause your video. All right, let's see how we did. We have the square root of -5, and we are timesing that by the square root of 20. Well, here again, that negative is the same thing as -1 times 5. -1 is I squared, so you can make that substitution here. And then you can pull out that singleton I. Now, one of the things that I have not addressed, I keep reinforcing that I squared is equal to -1. In that first slide, I told you because you can actually take the square root of both sides, I, by definition, is the square root of -1. So if you don't like making this substitution here, you can really just say, well, I know that square root of -1 is I, and just pull that I out in the first step. So that actually is an option for you. Our 20 is the same thing as 4 times 5. If you like that, you can say, 4 is a perfect square. I'm going to pull that out as a 2. If you don't like that and you want to keep your factor tree going, feel free. Let's do this multiplication. 2 times I gives me 2i. Square root of 5 times square root of 5 is square root of 25. Square root of 25 I know is 5. So 2i times 5, which gives me a final answer of 10i. Number 10, you have a binomial, 4 plus 5i, times another binomial, 4 minus 5i. Binomial times a binomial, I am going to FOIL. 4 times 4 gives me 16. This gives me a -20i. This gives me a positive 20i. 5i times a -5i is a -25i squared. Look at what happens here. You have a positive and a -20i, so those are going to drop out. I have an I squared here, which I know is a -1. So this is really -25 times -1, which is going to leave me with 16. I'm adding 25 on, and that sum is 41. All right, last problem. 3 minus 2i quantity squared. Well, 3 minus 2i quantity squared, you are not going to distribute that 2 through. No, you are not. That means that I have 2 of these binomials. I have 3 minus 2i, and I also have a second 3 minus 2i. A binomial times a binomial means we are foiling. 3 times 3 gives me 9. Minus 6i, minus another 6i. Negative times a negative is a positive, so 4i squared. This time, these guys do not drop out because they are both negative. However, I do again see that I squared. So I'm going to have to make a substitution there. This would be 4 times -1. So to clean this up one more step, I have 9 minus 12i minus 4, or 5 minus 12i. All right, hopefully you're doing great. One more type of problem. We are going to be working on division. Now, in example 8, you have a binomial in the denominator. Example 9, you just have a monomial. Now, the problem here, I squared is -1. And again, I, by taking the square root of both sides, is the square root of -1. Well, here in this problem, with leaving this I in the denominator, that really means I'm leaving a square root in the denominator. We do not want square roots. So when we were working with radicals, we were multiplying top and bottom by some value that is going to get that root out of the denominator, and that value was called the conjugate. So the conjugate means you are keeping the same two numbers for this binomial, but you're changing the operation. So I have 1 plus 3i, and I'm going to multiply that top and bottom by 1 minus 3i. And I'm using parentheses just so that I don't forget to distribute. So here we go. 8i times 1 gives me 8i minus 3i times 8i is going to give me 24i squared. In the denominator, 1 times 1 gives me 1. I have a negative 3i. I also have a positive 3i. And 3i times negative 3i is a negative 9i squared. Just like we saw before, these guys are going to go away. I have this negative 1 that I'm going to substitute in here for the I squared. So my denominator now is 1 plus 9, or 10. And my numerator, woo, same thing. I've got a I squared where I'm going to have to make a substitution again. So much fun. So I have this 8i, 24 times I squared, which is really 24 times negative 1. So I'm actually going to add on a 24 here because I had a negative. I was subtracting a negative value. So that's going to be, so this is really going to be an addition sign here. So I'm left with 8i plus 24 all over 10. I'm going to reduce that by taking a 2 out of each one. So 2 out of the 8 gives me a 4. 2 out of the 24 gives me a 12. And 2 out of the 10 gives me a 5. All right. One more example for the day. You have an I in the denominator for this one as well. However, I don't need a conjugate because I just have one term, just the imaginary part in the denominator. So I need to make this an I squared. I need to somehow get rid of that I. So now I'm not going to use a conjugate. I'm just going to multiply top and bottom by I. So I do still have to distribute here. Oops, that's a typo. I meant this in the numerator. I apologize. To be 4 plus I. And the bottom has a 2i. So let's change that. 4 plus I. Otherwise, it'd be a pretty silly problem. So I am going to still distribute in the top. I have 4i. I times I is I squared. In the bottom, I have 2i squareds. And again, I have to go back to this definition over and over and over. I squared is negative 1. So making that substitution here and here is going to take me to 4i plus a negative 1. In the bottom here, I'm going to have 2 times a negative 1. So I'm going to have 4i minus 1 all over negative 2. Now, some teachers don't like you leaving a negative in the bottom. If you are going to reduce that, you're basically dividing each term by negative 1. So this form actually is not ideal because you normally want the real portion first. So I'm going to divide each term by negative 1, and then I'm going to interchange these terms on the top. So if I divide this by negative 1, it's going to be a negative 4i. If I divide the negative 1 by negative 1, it's going to give me a positive 1. And then taking the negative out of the bottom gives me a positive 2. So here we go, our most simplified form. Similar to the format of all of the others, I would like you to give these a shot. Please pause your video and see what you can do. Here we go. Last two. I have a ratio, but this one seems kind of fun. Not only do I have an imaginary term in the bottom, but I also have a square root, just to kick it up a notch. This is a binomial, so I'm going to multiply top and bottom by a binomial as well. I'm going to use, again, what's called the conjugate. So I'm going to keep these same two values. This is a minus. I'm going to make it a plus. So same numbers, opposite operation. Let's go through and distribute. 3 times root 2. 3 times 5i. Square root of 2 times square root of 2 gives me square root of 4 or 2. Square root of 2 times 5i gives me 5i root 2. Negative 5i times root 2 is negative 5i root 2. And negative 5i times a positive 5i is a negative 25i squared. So again, a couple things that happen in the bottom. Number one, these guys drop out. One's plus, one's minus. That's the whole concept of using that conjugate. I have the I squared again, which I'm going to make a negative 1. So I have negative 25 times negative 1. Hopefully this simplifies real pretty. So the top is going to become, or stay, 3 root 2 plus 15i. And the bottom, I'm keeping this 2. I have a negative 25 and a negative 1, which is going to give me a positive 25. So I'm going to have to add that on. And my last step, 3 root 2 plus 15i all over 25, 26, 27. Holy smokes, I just realized I can actually go further. Each one of these values is divisible by 3. So I have one more step to go. If I take a 3 out of the first one, it's just going to leave me with a square root of 2. 3 out of the second one leaves me with a 5. And 3 out of the third one leaves me with a 9. Wow, quite a problem. Last one, you have two binomials. This one's going to be fun. 3 minus I and 2 minus I. Looking at this binomial in the bottom, and I know when I look at that, I'm going to want to be multiplying top and bottom by its conjugate. So I'm going to put parentheses around all of my binomials here, including the numerator. If I had 2 minus I in the denominator, I'm going to multiply top and bottom by 2 plus I. I'm not worried about that binomial in the numerator because, again, my goal is just to get rid of that imaginary in the denominator because that I is the same thing as the square root of negative 1. You cannot leave a negative or cannot leave a root in the denominator of a fraction. So I have a lot of foiling to do in the top. That's going to give me 3 times 2, which is 6, plus 3i, minus 2i, minus I squared. In the bottom, I have 2 times 2, so 4, plus 2i, minus 2i, minus I squared. Now, denominator again, same as all the others. These are going to drop out for us real nice. Clean that up. I don't see anything else that's going to really be that pretty. So to look at the numerator, these guys I can combine. But again, similar to all the other problems, I've got these I squareds where I'm going to have to make a substitution. So I'm going to do that in one long step here. I have my 6. These middle terms, 3i minus 2i is going to simplify to 1i. I'm subtracting I squared, which is a negative 1. So keeping with the numerator, I now have 6 plus I plus 1. So my final form in the numerator then is going to be 7 plus I. In the denominator, these guys dropped, so I have 4 minus I squared. I squared is negative 1, so this is going to be 4 minus a negative 1, and a negative is going to be 4 plus 1, so that's going to leave me with the 5 in the bottom. All right, quite a long video. Hopefully that helped a little bit. Have a great day. Thank you so much for paying attention. See you tomorrow.